Welcome to iTTV for Form 2 Science, where we continue our journey through the world of our senses. Today's lesson is light and sight. We've already investigated the eye, the sense organ that detects the stimulus of light. Today what we want to do is have a closer look at light itself. Now, you've already learned about light in primary school during your UPSR days. But now we just want to have a bit more of a look at light and recall some of the main characteristics and main laws of light. Firstly, let's start by defining what light is. Light is a form of energy. Light is an energy that is produced by any material or object that is illuminated. Our best source for light is obviously the sun, but we also have other sources of light such as the bulb or a television set or even plain old fire. All of these produce light energy. Light travels at a speed of 300 million meters per second. That's roughly about 300,000 kilometers per second. Now, light is extremely fast, and as far as we know, there are no other objects or energies, for that matter, that can travel faster than the speed of light. So please remember this number, 300 million meters per second, or if you wrote it in standard form, it would be 3 times 10 to the power 8 meters per second. Light travels in straight lines. Example, eclipse of the sun. Now, in primary school, you learned that light traveled in a straight line. If there was something blocking the light, it would cause a shadow to be created. One of the examples of this is during the total eclipse of the sun or even a total eclipse of the moon. Because of the earth blocking the moon suddenly disappears from our view. This is a total eclipse of the moon. Sometimes the moon gets in the way between the sun and the earth. It blocks the light and we get what is called a total eclipse of the sun. Both these phenomena prove to us that light travels in a straight line. Reflection of light takes place when light rays fall on the surface of an opaque object and bounces off it. Now, before I continue and explain what this slide is actually talking about, let's just clear up this thing about the word opaque. Opaque is a material that does not allow light to pass through it. The opposite of opaque is transparent. So you would say that the door to your house, which was made of wood, was opaque. But if you had a door made of glass, then it would be transparent. So remember, opaque objects don't allow light to pass through them. What they do is, opaque objects reflect the light back to us. They allow the light to hit the object and bounce back. Now, the main characteristics that we are looking for in the object so that it is a good reflector of light is that A, it needs to be with a very smooth surface. And secondly, it needs to be quite shiny. If you have a dull surface that is rough, although it is opaque, it is not a good reflector. A flat and smooth surface, like a mirror, reflects light in a regular pattern, namely regular reflection. So, if you have a flat surface and that it's smooth, these are the perfect conditions for reflection. Let's just go up here to the board for a moment and demonstrate what we're talking about. So let's say I have a flat object that is smooth. If I have a flat object, so this is both flat and smooth. If you have an object that is flat and smooth, what you'll find is the light will reflect evenly off the object. Meaning, if a light ray comes in from over here, draw the arrow, it will reflect back very evenly like so. So remember, what's the key here is flat, smooth. So remember, the two main things for regular reflection is flat and smooth. But what happens if we have a surface that is rough and not smooth? When light falls on irregular surfaces, rough, like paper and cloth, the reflected light rays are scattered in different directions, namely diffused reflection. Now, in the case of diffused reflection, what occurs is the light scatters to all directions, which means we don't get enough light entering our eye, so it's very hard to see the reflection. Let's have a look at this on the board. Now, it looks as if the surface is smooth, but when you take a closer look at the surface, example here, and let's just make this a bit larger here, what we actually see is that the surface is actually very, very bent. So this is what we mean by a rough surface. I know you think that when you see a paper, it's smooth, but actually, if you look at it very finely, it is rough. So what occurs here is, as the light comes in, this light ray, instead of bouncing regularly this way, ends up flying this way. Or a light ray coming in this way, instead of bouncing this way, bounces back this way. So this is what we mean by diffused reflection. And in the case of diffused reflection, we don't really see the reflected object. The law of reflection, angle of incidence is equal to the angle of reflection. So finally, we have the first law of reflection. And the law is a very simple law. It says that the angle of incidence is equal to the angle of reflection. Now, in order to work this out, once again, we'll go to the board over here. If I draw my smooth surface like so, the next thing we need to do is draw in what is called the normal. The normal is a line that is at 90 degrees to the surface. It represents a ray of light that is traveling at 90 degrees. Anything that travels at 90 degrees straight down like so will bounce straight back up. So this line is what we call the normal. The angle of incidence will come in on one side of the normal. So over here we have our incident ray, which produces an angle over here, I, which is the angle of incidence. On the other side of the normal, we will have the reflected ray, like so. This ray produces an angle with the normal over here. This is called the reflected angle. The angle of incidence is equal to the angle of reflection. I equals R. Let's try a very quick question.
Say something.
Now, sorry, I was just quickly drawing that for you. If you have a look at this diagram that I've done, you can see that the angle of incidence is 40 degrees. Okay? The angle of incidence is 40 degrees. What is the angle of reflection? Now, according to our law, the angle of incidence is equal to the angle of reflection, which means that if this angle is 40, this angle must also be 40. So please understand, the angle of incidence must be equal to the angle of reflection. Applications of the reflection of light. Periscopes are used in submarines to observe objects outside the submarine. So one of the instruments that uses the idea of reflection is the periscope. Application of the reflection of light. A dentist uses a mirror when examining a patient's teeth. Now, we all use mirrors to comb our hair, to dress up, but for a dentist it's especially important, especially when he or she wants to look at your teeth right at the back of your mouth. Now, obviously you can't put your head in there and have a look, so instead they use the simple idea of a mirror reflecting. They put a mirror inside, they can see the reflection of your tooth. Is there any decay there? Is there a cavity there? Does it need a filling? What's wrong with it? So this is a very clear example of using the idea of reflection. Now that we've learned a bit about light and reflection, let's try a few questions on the topic that we have just done today. Question 1. Describe how light travels. Now, remember, we were talking about eclipses and shadows being formed. They gave us an idea how light traveled. Have you written your answer down? Let's test and check. In a straight line. So, light travels in a straight line. Let's move on to another question. What is the law of reflection? What is the law of reflection? Try to recall the question that we did on the board. I said that if the angle of incidence was 40, we found that the angle of reflection was also 40. So what does this tell us about the law of reflection? The answer, angle of incidence is equal to the angle of reflection. Good if you got that right. Let's try one last question. What type of reflection occurs on a rough surface? Now we have two types of reflection. One is called regular reflection. One is called diffused reflection. Which one do you think occurs on a rough surface? Have you written your answers down? Good. Let's check. Diffused reflection. So, diffused reflection occurs on a rough surface. Now that we've tested our knowledge on reflection, let's have a look at the next major light phenomena that is very, very essential to us. This is called refraction. Not reflection, refraction. Refraction of light is the bending of light as it passes from one transparent medium to another. So, with refraction, we need a transparent medium. Remember, with reflection, we needed an opaque medium because the light was going to bounce back. With refraction, the light is going to go through the medium or through the object, but as it does this, it is going to bend slightly. Refraction of light occurs when the speed of light changes. So, why is it that the speed of light changes? Well, let's jump back to the board over here and try to explain it. Let's say that we have over here a block. Let's say that the block is made out of glass. Outside, surrounding it, is just plain old air. Now, as the light travels from the air into the glass block, so the light is traveling over here, like so. Once again, we must draw in our normal. Remember, the normal is at 90 degrees to the surface, so 90 degrees to the surface. Now, in the air, light is traveling at 300 million meters per second. But imagine when you go from air into glass. Well, try this. Imagine that you're on the beach and you're running from the sand into the water. When you enter into the water, do you travel faster or slower? Well, I hope you said slower, because that's what's actually happening. You slow down because the water is thicker, which means it is harder for you to go through it. There's more friction inside it. You have to get through more particles. Well, the same thing is happening over here. As the light travels from the air and enters into the glass is thicker, denser. As this happens, the light slows down. When the light slows down, its direction changes. The light will move this way. Instead of, imagine it should keep going straight, but it doesn't keep going straight, it changes direction. This phenomena, where light changes direction as it travels from one transparent medium to another transparent medium, is called refraction. So why is it so important to us? Well, the truth is, as light enters into our eye, it is refracted through the cornea, through the aqueous humor, through the lens, through the vitreous humor, until it reaches our retina. The focusing of light in our eye is very, very dependent on the phenomena of refraction. The speed of light decreases when light enters a denser medium. For example, from air to glass. Light bends towards the normal. So the key here is this. When you go from less dense to more dense, you move towards the normal. When you go from fast to slow, you move towards the normal. The speed of light increases when light enters a less dense medium. For example, from glass to air, or from water to air. Light bends away from the normal. So when you become faster, you move away from the normal. Why is this important? Well, I'll tell you. In your examinations, what they'll do is something like this. They'll draw a diagram. They'll label the inside here A. They'll label the outside B. They'll draw a light ray. They'll say, here's the normal. I have a light ray going this way and then going this way. Let's do the first part. Is it going towards or away from the normal? So if this is the original light ray here, it should go straight. In fact, what we see here is it's going away from the normal. Now, if it's going away from the normal, they will ask you this question. Which one is glass and which one is air? Remember, if you're going away from the normal, you must be going from more dense to less dense, which means that A must be the glass and B must be the air. So really very important that you know which way the light is bending, towards the normal or away from the normal, because it allows us to identify the material. Now that we've done a bit of refraction, let's try a few questions on refraction. What happens when refraction occurs? Remember, when refraction occurs, something happens to our light. Have you written your answers down? Let's check. Light bends. So remember, light bends when refraction occurs. Let's try another question. Which way does light bend when passing from less dense to more dense? So remember here, you're going from less dense to more dense, from fast to slow. There's only two options. Do you move towards the normal or away from the normal? Have you put your answer down? Towards the normal. So when you go from less dense to more dense, you move towards the normal. One last question. Which way does light bend when passing from more dense to a less dense medium? So remember, just now we did less dense to more dense. Now we're doing it the other way around. From more dense to less dense, slow to fast. Have you put your answer down? Away from the normal. So light bends away from the normal when moving from more dense to less dense. Now that we've tried some questions on refraction, let's have a look at some phenomena that we see in our daily life that shows us refraction. Phenomena of the refraction of light. The pond appears to be shallower than it really is. Now you would have noticed this in the swimming pool. You go into the swimming pool and your legs look a bit short. It isn't that you've shrunk, it's just the phenomena of refraction. The drinking straw in the glass of water appears to be bent. Well, we can actually do this in the lab. What I've got here is a beaker of water, and I'm going to put a pencil into this beaker of water like so. Now, if I hold this up for you over here, you should notice that the pencil looks bent. Never mind the straw, the pencil looks very bent. Now, the reason that the pencil looks bent is because of this wonderful phenomena, which is called, that's right, refraction. Let's try one more phenomena that will probably really get your juices flowing. The dispersion of white light into its 7 component colors of the rainbow is a phenomena of light refraction. Here the light is refracted as light passes through raindrops. On hot days, the surface of a road looks as though it's wet. This is called a mirage. A mirage is caused due to the refraction of light as it passes through the layers of hot air and cold air. So I hope you get an idea about light, especially in terms of reflection, which is against opaque objects, and refraction, which is the bending of light as it passes through transparent objects. That's all we have for today's lesson. Thank you for watching iTTV.